Hey guys, so today's lesson question, we are going to be focusing on what are the different energy systems which we use when exercising. So there are two key words that we need to be focusing on for today's lesson, and those words are aerobic exercise and anaerobic exercise. So, aerobic exercise. This is exercise which uses oxygen or it's with oxygen. This is when exercise is not too fast and is steady. The heart can supply all the oxygen that the working muscles need. Now, when we're looking at these systems, we have some equations that we need to look at. So these equations are what we use when we look at how the body is using glucose, oxygen, etc. The equation that we'll be using for aerobic exercise is glucose plus oxygen equals energy plus carbon dioxide plus water. I would suggest making note of this because I'm going to test you at the very end of the video. The next one we're looking at is anaerobic exercise. So this is short bursts of exercise. So anaerobic exercise is without oxygen. This is when our exercise duration is short and at high intensities. The heart and the lungs cannot supply blood and oxygen to muscles as fast as the respiring cells need them to. So this equation is glucose equals energy plus lactic acid. So lactic acid is that burning sensation that you might get when you do, say, 100, 200, 400 meter sprint. So, question for you. I would like you to think for yourself and maybe jot down on a piece of paper which of these sports use the aerobic system or the anaerobic system. So we have the long jump, we have football, we have the 100-meter sprint, we have a long distance run, potentially a 3,000 or a 3K. We've got the shot put and we have the rowing. So 6 different sports. Remember, we're looking at the aerobic and we're looking at the anaerobic systems. The aerobic system is going to be long exercise. Anaerobic system will be short bursts. So, if we come back over to the images, the long jump, the 100-meter, and the shot put are all examples of using the anaerobic system. They are short bursts of energy and they only last a short amount of time. So this differs to our football, our long distance run, and our rowing, all of which are longer periods of exercise. So we'll be going for much longer periods of time. So again, looking back at aerobic, they will be using the longer periods, because the muscles need more oxygen for long periods of time. So we're going to be having a look at quite a few exam questions in today's lesson. So to start off with, which activity is most likely to use the aerobic respiratory system for energy? Now, a reminder of the key word is aerobic. Aerobic. So aerobic, we've got the 10K, we have the vault in gymnastics, the shot put, and jumping to a blocker shot in basketball. So in terms of longevity and long exercise, the 10K is the most accurate and the most precise answer for this question. Question number 2. Which of the following equations summarizes the process of anaerobic respiration? So we're going to have to go back and think about those equations. So would it be energy equals lactic acid and glucose? Glucose equals energy and lactic acid. Glucose plus oxygen equals energy and lactic acid. And oxygen and energy equals lactic acid. Well, way to cancel this out. If we think about our anaerobic system, does it use oxygen? The answer to that is no. So we know that C and D already can't be used. So now it's just a matter of remembering whether it's energy equals lactic acid and glucose, or if glucose equals energy and lactic acid. So the answer to that is glucose equals energy and lactic acid. Okay. Sam, question 3. Acid production occurs when an athlete's body is digesting a large meal, working aerobically, working anaerobically, or sitting still for a long period of time. Well, we've already talked about that build-up of lactic acid, and we looked at that from a 100-meter perspective, or 200 or 400, and all of those types of exercise are anaerobic style exercises. So we should know that the answer to that would be C, working anaerobically. Which of the following athletics events is an example of aerobic activity? So we have the javelin, the 100-meter, the 5K, and the high jump. So we've already talked about the 100-meter. The 100-meter is a short burst. The javelin is also a short burst, and the high jump would be a short burst of energy as well. So the answer to that is the 5K or the 5,000 meter, because you're going to be using your aerobic system over a much longer period of time. Which one of the following is not an anaerobic activity? So again, anaerobic is a short burst of energy. So we have the long jump, we have the gymnastics vault, we have the tennis serve, and we have the yoga. So the answer to that would be the yoga, because the yoga is an aerobic activity. We'll be doing that over a longer period of time. 20 minutes, half an hour, a long period of time. A tennis serve, a long jump, or a gymnastics vault session tend to only last a very short period of time. Next question. Which one of the following equations summarizes the process of aerobic respiration? So we have glucose plus oxygen equals energy, carbon dioxide, and water. We have glucose plus oxygen plus carbon dioxide equals energy and water. We have glucose plus carbon dioxide equals energy plus oxygen plus water. And we have glucose plus water plus carbon dioxide equals energy plus oxygen. Now, we know, based on our previous learning, that for the aerobic respiration system, we must use oxygen as part of our respiratory system. So that means that C and D cannot be the answers. Now, in terms of taking on carbon dioxide, that doesn't often help with the respiratory system. Usually your respiratory system will be putting that out. So the answer to that question would be A. Glucose plus oxygen equals energy plus carbon dioxide plus water. That's going to be your output. Longer questions now. So, describe a situation in which a performer would be working aerobically. This is a 2-mark question. So if we have a look at the marking guidelines, so A01, we're looking at the knowledge. So we would look to award 1 mark for identifying a key characteristic of aerobic activity, such as perform at a steady or moderate intensity, requires oxygen for energy production, or lasts longer than 2 minutes. We would also look at application, so we would award 1 mark for providing a specific example of an aerobic activity and linking it to the characteristics. such as running a marathon because it requires sustained effort over a long period of time, or swimming continuously at a moderate pace. So an example answer we have here is running a marathon is an example of working aerobically because it involves maintaining a steady pace for a long duration using oxygen to produce energy. Next question. Describe a situation in which a performer would be working anaerobically. So a very similar question, but we need to make sure that we look at the key word, which is anaerobically. Anaerobically. We must keep that word in mind. So in terms of the mark scheme, very similar, but for this particular question, instead of looking at the aerobic system, we're looking at anaerobic. So we would be looking at either performing at a high intensity, not relying on oxygen for energy production, and typically lasting less than 2 minutes. For the application, we'd be looking at something along the lines of sprinting 100 meters, as it involves maximum effort for a short duration, or completing a set of heavy weightlifting reps due to the high intensity and short time frame. So an example answer may be sprinting 100 meters is an example of working anaerobically because it is a short, high intensity activity that does not use oxygen for energy production. We have a question now based on Michael Johnson. So we're going to look at what energy system Michael Johnson is using for the 400-meter sprint. So for context, this is the current world record. It is 43.03 seconds. He holds the current 100-meter record, which is 9.58 seconds. And his split times for each 100-meter in his race is 10.7 seconds. So let's have a quick look at his race. Okay, that just gives you some context for what he can do. Okay, so exam question. In 1999, Michael Johnson set a new world record for the 400-meter with a time of 43.18 seconds. Justify why his performance was mainly aerobic or anaerobic. So, tricky question. Very tricky question for the 400 meters. It's a 4-mark question, so let's have a look at how we would break that down. So we would look to describe that this would be using the anaerobic system. The anaerobic system. So that would be your 1 mark. So for another 3 marks, you would then need to break down why. So 400 meters is a sprint event, and all sprint events are anaerobic. Maximal intensity and effort and low duration means insufficient oxygen is available to work aerobically. Energy demand is higher than oxygen available, therefore anaerobic. No reduction in intensity or time to rest to repay oxygen debt. Body uses glucose to energy plus lactic acid because of the lack of oxygen. So any of those responses, putting 3 of those different responses in your answer would get you the marks. Of course, there are other suitable justifications as well. So here is an example of a response. So Michael Johnson's performance in the 400 meter was mainly anaerobic. This is because the 400 meters is and all sprint events rely on the anaerobic energy systems. The race is completed at maximal intensity with insufficient time or oxygen available for the body to work aerobically. The high energy demand exceeds the oxygen supply, meaning energy is produced anaerobically, resulting in the production of lactic acid. So there is a model answer that you could use in your exams. So a quick reminder of what we looked at in today's lesson. So we looked at aerobic exercise, which is using oxygen when exercise is not too fast and steady. The heart can supply all the oxygen that the working muscles need. And we looked at the anaerobic exercise system. So without oxygen, when exercise duration is short and at high intensity, the heart and lungs cannot supply blood and oxygen to muscles as fast as the respiring cells need them.